In this video, I'm going to talk to you a little bit about the normal model, the empirical rule, and z-scores. The normal model, also called the normal distribution, is a unimodal, symmetric, bell-shaped curve centered at population mean mu. It is generally represented with 3 standard deviations above and 3 standard deviations below the mean. And this symbol right here that I'm writing, -2, that's lowercase sigma. That is a Greek letter, and it stands for the standard deviation. Now, the normal model is extremely useful, particularly in the sciences. One of the reasons the normal model is so useful is because of something called the central limit theorem. The central limit theorem tells us that with repeated random sampling of data from a population, we can expect the results to fall into this bell-shaped distribution. And time again, throughout the years, it has been shown that this model works. With repeated random sampling from a distribution, we often see that the distribution takes on this unimodal, symmetric, bell-shaped curve. So, we can apply the empirical rule to the normal model to help us answer questions about these data. The empirical rule is sometimes called the 68, 95, 99.7% rule. And what the empirical rule does for us is it allows us to partition the bell curve and make some generalizations. For example, in a unimodal symmetric normal model, we can expect 68% of our data, randomly collected from some population, to fall within 1 standard deviation of the mean. We can expect 95% of our data to fall within 2 standard deviations of the mean. And we can expect 99.7% of our data to fall within 3 standard deviations of the mean, 99.7%. This is very useful, but it works best with large populations. Now, we can further subdivide our bell curve using the empirical rule because of its symmetry. So I know that if 68% of my data falls within plus or minus 1 standard deviation of the mean, then between the mean, population mean mu, and 1 standard deviation above the mean, I can expect to find 34% of my data. And the same can be said for population mean mu and 1 standard deviation below the mean. Here I'll also find approximately 34% of my data. Now, between 1 and 2 standard deviations above the mean and 1 to 2 standard deviations below the mean, I can expect to find 13.5% of my data. So in other words, 13.5% of my results I might expect to find between 1 and 2 standard deviations above the mean. Now, between 2 to 3 standard deviations above or 2 to 3 standard deviations below the mean, the empirical rule tells us that we can expect to find about 2.35% of our data. The empirical rule is very useful for answering certain types of questions about our data. For example, let's suppose that the mean IQ happens to be 100 with a standard deviation of 15. So here is my mean of 100. That means I'll have 115, 130, and 145 for 1, 2, and 3 standard deviations above the mean, respectively. I'll have 85, 70, and 55 at 1, 2, and 3 standard deviations below the mean. Now, suppose I asked you, what percentage of the population can we expect to have an IQ of between 100 and 115? Well, by the empirical rule, that answer would be 34%. If I said, well, what percentage of the population can I expect to have an IQ that's between 2 and 3 standard deviations below the mean? Well, by the empirical rule, that would be approximately 2.35%. So you can see the empirical rule is very, very useful. However, what if I ask you the following question? How far above or below average is a person whose IQ is 123? The empirical rule is not so helpful in answering this question for us. But we can use something called a z-score, which helps us to take our data and standardize it. In other words, by creating the z-score for a particular piece of data, we are standardizing it to scale it along the normal model. And so the formula that we'll use for the z-score in this instance is z equals a data point minus my population mean divided by sigma, my standard deviation. So to find out how far above or below average an IQ score of 123 might be, clearly we can see it's above average, but for the purposes of what we're doing here, let's pretend we don't know yet. I'll take my data point, 123, minus my population mean of 100, divide by the standard deviation of 15. That gives me 23 divided by 15, which gives me 1.53. So z equals 1.53, and I can now tell you that a person with an IQ of 123 would be approximately 1.53 standard deviations above the mean. So there you have it, a quick summary of the normal model, empirical rule, and z-scores.